Hi, hello friends. Welcome to Sandeep'S diary. In today's class, we are going to deal with acid, bases and salts, that is class 10's chapter 2. I have divided this chapter into 4 main parts. Those are part 1, understanding the chemical properties of acids and bases. Part 2, what do all acids and bases have in common? Part 3, how strong acid or base solution, and part 4, more about salts. So in this video, we are going to discuss with the part 1. We are going to understand all the chemical properties of acids and bases. Without wasting time, let's move on to the video. So now let's move on to the introductory part. That is about indicators. What are indicators? Indicators are those which is a chemical substance basically used to detect a solution acidic or whether it is basic. So indicators are those which will be added to the particular solution in a very small amount. So that will help us to find whether a medium is acidic or basic. Basically, there are two main types of indicators. Those are acid-base indicators and olfactory indicators. So let's talk about them. Acid-base indicators and olfactory indicators. That is nothing but in acid-base indicators, we will identify the odor, color in different acidic or basic medium. But in olfactory indicators, they will show one odor in acidic medium and the other odor in an basic medium. Okay, so one odor in acidic and different order in basic. Okay, in acid base indicators we have so much examples. Let us list them down. That is methyl orange, next phenolphthalein, next in olfactory indicators we have vanilla essence, clove oil and etc. So these are basically acid base indicators and olfactory indicators. Now let's discuss about the acid base indicators. So now about acid base indicators. Acid base indicators are of two types. One is natural acid base indicator and another is synthetic acid base indicator. What are the examples of natural acid base indicators are litmus, red cabbage, and coming to synthetic indicators, they are methyl orange and phenolphthalein. So these are the types of acid base indicators. So now let's talk about what color they show in acid base medium by these indicators. Let's first talk about litmus. So litmus in acid will show us red color. Litmus in base will show us blue color. Litmus in salt, it will show us purple color. Then methyl orange. In methyl orange in acid will again show us red color. Methyl orange in base will show us yellow color. Methyl orange in salt will show us orange color. Now let's talk about phenolphthalein. Phenolphthalein and acid, it is colorless. And phenolphthalein base, it is light pink in color. Then phenolphthalein in salt medium, it is again colorless. So this table is a very important table and you have to memorize. So they will be asking you in 1 marks too. So now let's talk about acids. Acids are basically sour in taste. Okay, they are sour in taste. And what acid liberates in aqueous solution? So in aqueous solution, they liberate H plus ions. Okay, in aqueous solution, they liberate H plus ions. Then blue litmus paper will be turned into red litmus paper if I dip into acid. Then if I dip red litmus paper in acid, there will be no change. There will be no change. Then methyl orange. Acid in methyl orange will give us red color. Then acid in phenolphthalein will remain colorless. Okay, these are some basic properties of acids. So now we are going to talk about the strength of acids. The strength of acids will be based on strong acids or weak acids. Now let's talk about strong acids. Strong acids are those that acids undergo complete dissociation in aqueous solution and they produce high concentration of H plus ions are known as strong acids. Okay, for example HCl. So HCl is a type of a strong acid. Now coming to weak acids. Weak acids are those acids that undergo partial dissociation in aqueous solution and produce low concentration of H plus ions are known as weak acids. So for example, H2PO4 is a type of weak acid only. Let's talk about basicity of an acid. So what is that? That is nothing but number of replaceable H plus ions in an acid is known as basicity of an acid. So how much number of H plus ion can be replaced? For example, we have divided that into monobasic, dibasic and tribasic and we'll talk them with an examples. So HCl, see only one H is present, so H plus will be liberated out, only one H plus will be liberated out. Similarly HNO3, here too one H plus will be liberated out, and CH3COOH, here too one H will be liberated out. Coming to dibasic, here H2PO4, H2CO3, H2SO3. See, 2 H plus ions can be liberated out. That is dibasic. Di means 2, right? Mono means 1. Tri means 3. For example, H3PO4. 3 H plus ions can be liberated out. So this explains the basicity of an acid. So now we are in the end of the session. So let's complete with the note point. That is nothing but the acid should be added to the water. Water should not be added to the acid. If we add water to the acid, they will be highly exothermic. Exothermic means heat will be evolved out. Okay, a huge amount of heat will be evolved out, which is very dangerous to us. So always add acid to water. By doing this, you will not get that much effect, and you have to do constant stirring. You have to do constant stirring of the solution so that the process will not be exothermic. So that's all for today, friends. Let's meet on the next video. Until then, bye.